In today's lesson, we will look at sample tricks and techniques under the GRE Quantitative section to demonstrate how GattPrep can help you learn and master these tricks to ensure you do well on the test. Remember that the GRE is a timed test with no time to waste. To ensure success, you must master these tricks and techniques to enable you to speedily and accurately maneuver the test. We will take a look at tricks and techniques under number properties and fractions, decimals, and percents. Under number properties, we'll look at rules of divisibility and counting integers. Under fractions, decimals, and percent, we'll look at comparing fractions and terminating versus non-terminating decimals. Now we'll take a look at rules of divisibility under number properties. Divisibility rules are important and necessary shortcuts to help you quickly determine whether an integer is divisible by another integer. These shortcuts will save you time on the test. Now, before we dive in, what is divisibility? Divisibility is when an integer divides another integer and the result is an integer. So let us see what happens when we divide an integer by another integer. Say 15 divided by 5 yields the integer 3. Now, because 3 is an integer, we say that 15 is divisible by 5. Now, 13 divided by 2 yields a decimal 6.5, and 6.5 is not an integer. And so we say that 13 is not divisible by 2. Now, when can we say that an integer x is divisible by another number, say 2 or 3 or 9 or 10? We are not going to go through all the rules of divisibility. We will take a look at the rule for dividing by 3. Now here it says that this is the rule. An integer x is divisible by 3 if the sum of the integer's digits is divisible by 3. So if we pick a number, say 69, how would you be able to determine that 69 is divisible by 3? Well, very easy. The rule says that if you sum the individual digits and the sum of these individual digits, if that sum is divisible by 3, then the number is divisible by 3. And we can tell that the sum, which is 15, divides 3 and gives us what? 5. And because 5 is an integer, then 69 is divisible by 3. And so how is this rule useful? Now let's look at this example where you have this number 6237, which is not so easy on the eye. How can you determine if this number is divisible by 3? Same rule. So we sum the individual digits. Okay, and this is what? This is 18 and this is 6, and therefore this number is divisible by 3. We can confirm this by using what? The long division method. So 3, you have 6, 2, 3, 7, 3 will go into 6, 2, 3 will go into 23, 21, and then you have 27 here, 3 will go into 27, 9, and then it leaves no remainder. So you can see that this rule will work for you. Now, what is the essence of rules of divisibility? Now we have rules for 2, for 4, for 5, for 6, for 8, for 9, and for 10. Now, these rules will help you to be able to deal with numbers. If you have to break down numbers, you can easily see, with your eye that the rule for 4 will work, or the rule for 8 will work, or 9 or 6, and you don't have to do a lot of cumbersome computations. Now, we'll now take a look at counting integers under number properties. Now, take a look at this example. Now, from this example, it says how many even integers are there from 12 to 24? Now, it is very easy to list all the even numbers between 12 or from 12 to 24. And then we can say 12, 14, 16, 18, 20, 22, and 24. There are 7 terms. Now, let us look at this second example. It says that how many multiples of 5 are there between 22 and 632? Now, here you can tell that, this is what? A very long consecutive pattern. Now, do you have to methodically count each term in this, series? The answer is no. No, you have to just remember that, if both extremes should be counted, you take the difference of the last and the first numbers, and then you divide by the increment and add 1 before you are done. And so here there's this simple formula which says that what? The last number minus what? The first number divided by what? The increment, okay, plus 1. Will help you to be able to, count all the multiples of 5 between this one and this one. Now let us attack the question. So here in this example, because 22 and 632 are not multiples of 5, you need to find 2 numbers, okay? If you put 22 and 632 on a number line, you need to find 2 numbers. Okay, the first one is the closest multiple of 5 greater than 22, and the closest multiple of 5 less than 623. Oh, sorry, 632. Now here, on this side, you could tell that the closest multiple of 5 to 22 is what? 25. And the closest multiple of 5 closer to 632 is 630. So we found the 2 numbers. Now, once we found these 2 numbers, we can proceed to finding our solution using the formula. And so here you have what? The last number being 630 and the first number being what? 25. All divided by what? The increment, which is what? 5. Because here we are looking at multiples of 5. And if you are looking at multiples of 5, you will realize that the increment is what? 5. 5, 1, 5, 5, 2, 10, 5, 3, 15, 5, 4, 20, 5, 5, 25. So you realize that the increment is 5. It jumps by 5. 5 plus 5, 10, 5 plus 5, 50, 10 plus 5, 15, 15 plus 5, 20. So we divide by the increment, which is what? 5. And then we add 1. So here, 630 minus 25 is what? 605, all divided by 5 plus 1. And then this one yields what? 605 divided by 5 is 121 plus 1, and then this yields 122. Now if you want to use this to solve this, it's very easy. Similar stuff. We can come back here and then use the formula and say, okay, we have how many even integers are there from 12 to 24. We can say the last term is 24, the first is what, 12, and so 24 minus 12. Remember, even integers, they increase by what? 2 divided by 2 plus what? 1. And so you have 24 minus 12 is what? Is 12 divided by 2 plus 1. 2 divided by 12 is what? 6 plus 1. 7. Remember, we had 7 terms. 1, 2, 3, 4, 5, 6, and 7. And so yeah, very, very simple stuff. Now we will take a look at comparing fractions under FDPs, fractions, decimals, and percent. Now here we take a look at this example, which is which fraction is greater, and we have 6 over 7 or 5 over 6. Now the shortcut to comparing fraction is by cross multiplying. Now this involves multiplying the numerator of one fraction with the denominator of the other fraction and vice versa. So here 6 will move and multiply this 6, 7 will move and multiply this 5. Now we have 6 times 6, which is what? 36, and then 5 times 7, which is 35. Now here remember that you have to put each answer by the corresponding numerator. And so here, if you don't move the denominator to multiply by the corresponding numerator, you will run into errors. So for instance, there could be a situation where instead of moving the denominator to multiply the numerator, you would rather move the numerator to multiply the denominator. And then if you have your numbers going this way, you can have 7 times 5, and then you have this one coming this way, you have 6 times 6, then 7 times 5 is 35, and then 6 times 6 is 36, and you will end up saying that you will end up doing this, and you see that this fraction is bigger. And so we have to take note of the direction of the multiplication. You cross multiply, and move the denominator to multiply the numerator when comparing fractions. Now here, in this example, it says which is greater, 123 over 250 or 163 over 320. If you see this question on the exam, you cannot use the cross multiplication rule to solve. There is a different technique. Now, I'm not going to solve this one, but if you decide to sign up with us, we will make sure to equip you with all the tricks and techniques you need to excel on the test. Now we'll take a look at terminating versus non-terminating decimals and fractions, decimals, and percents. Now dividing an integer by another integer could yield a decimal that either terminates or that never ends and repeats itself. Now here we have this example, 1 divided by 9, and this one will yield 0.111111, which is approximately equal to 0.1 bar, and the bar above the digit 1 depicts that 1 repeats itself infinitely. Now there's a pattern for when you divide 1 by 9, and I can show you 2 divided by 9 is what? 0.2222, and then this one is what? 0.2 bar. 3 divided by 9 is 0.33333 is equal to what? 0.3 bar. Now, the rule here is that if the denominator is 9 or 99 or 999 or another number equal to a power of 10 minus 1, then the numerator gives you the repeating digits depending, on whether you have 1 digit or 2 digits. Okay, now because of how special the result is when you divide by 9 or another number equal to a power of 10 minus 1, we can convert fractions like 1 over 11 and 3 over 11 to have a denominator which can be easily computed using this rule because we know the pattern. Okay, and so here, if you have, a fraction with the denominator being 11, it's very easy, okay, to say, let's multiply this by a placebo fraction. 9, multiply this by 9 and divide by 9. And I call this 9 over 9 a placebo fraction because it's simply 1. And 1 times 1 over 11 is 1 over 11. It helps us to be able to simplify, but it does not change the integrity of our solution. And so 9 times 1 is 9, 9 times 11 is 99, which is what? 0.0909, and then it's approximately 0.09 bar. We can do the same with this 9 over 9 placebo fraction, and then 9 times 3 is what? 27, and then 9 times 11 is 99, and then here it gives you this nice pattern 0.2727, which is approximately 0.27 bar because 27 will repeat. And so here you can see that if you are dividing by a number by 9, x over 9 or x over 99 or x over 999, there's a clear pattern, which is very beautiful to see. Now, there's a clear pattern I want you to take note of. If you divide an integer by 3, 7, and 9, and the result is not an integer, then the resulting decimal will repeat. There's a very nice rule for 3 and for 9, as we have just seen. Now, how about 7? There's a trick for finding the solution in a decimal form when you divide an integer by 7. I'm not going to go into that today. As I've already mentioned, if you decide to sign up with us, we will make sure to equip you with all the tricks and techniques you need to excel on the test. This brings us to the end of the sample tricks and techniques under the GRE Quantitative section. For more information about our GRE, GMAT, and SAT programs, please contact us at info@GattPrep.com or at 306-880-1603. Visit our website at www.GattPrep.com.